Hello everyone, guys. Today I'm gonna show you guys our file manager that we made. We called it Panda File because I love pandas. All right, let's go ahead and check it out. This is a basic file system which has creating, opening, reading, and writing files in the RAM. But we want even past that. We built like a Unix-like file system which includes nodes, block allocation, directory, hierarchical directories, and multi-user permissions, and a bunch of other features. Let's go ahead and hop in. I'm gonna go ahead and start it. Oh yeah, we have sounds. Did you guys hear that? All right, let's go ahead and open up 100 blocks. Let's go check out our path. Look at that directory. And look at all the commands we have. Wow, do you guys see all these commands? It's crazy. We divide it into different commands. We have one for file management, navigation and directories, files, search, metadata. There's just a whole bunch. All right, let's go ahead and make a directory, guys. Let's make it home directory. Let's go make another one. Let's make it one called Brandon
Yay.
and another one for Eric and another one for our data. And dude, data has to be stored inside a project, so let's go ahead and make one for that too. All right. Let's go and go to our home directory. Check it out. We see that we have Brandon and Eric files inside the home directory. Let's go inside Brandon. And we can see we could also move. We can move outside this file. All right, we're back in home now. And let's go ahead and move again. Right, so do you guys see how we have like absolute paths like home and relative paths like Brandon? We could use special entries like dot dot to navigate to the parent directory. Now let's go ahead and make some file descriptors. Check that out. Let's go to Brandon again. All right, let's go ahead and make notes.txt. Oop. All right, so we just made a notes.txt. Let's go make another one called to do. And let's check that out. Oh, yep, our files are right here. Pretty good. And let's go ahead and open it so we can write. All right, so we see that FD is 26, so let's go ahead and write to that. 26. Let's say hello. This is the Panda team, the file team, yo. We could also append some text to it too. That's pretty cool. Let's go ahead and do that. Hey, we can append. Sweet. And now that we appended, let's go ahead and close this file. And let's go ahead and read it now. See? Oh, we just read it. Check it out. And let's go open the to-do file and write to it. See TXT and write mode. Perfect, perfect. And we see this is FD33. So let's write. We are currently doing the presentation. Cool. And let's go ahead and close it now. And let's go check it out. Oh, see right there, I wrote. Now let's go demonstrate the seek operation for random access. Let's go ahead and read that. Let's see, open notes.txt in read mode. Now let's go read. Let's go read this, and let's go ahead and read, let's say 10. Yeah. See, so it just says hello this. I'm go ahead and use the seek function now. We can see that the new offset is now 0. And let's read it again to show that the offset worked. Oop. See, now it just says hello. We can see that the offset worked. And let's go ahead and close this file. It's closed. All right, so this just demonstrates how we could open file and we could open return a file descriptor and write, and we use write and read during that descriptor. And we can see that all the data is stored in our simulated RAM. Next, this is a really cool feature. Oh my God, I had so much fun doing this one. Check it out. We have a tree. All right, let's go move to the tree. Oop. See, do you guys see how we have our whole entire file is mapped to a tree? See, data has projects, home has Brandon and Eric, but Brandon has notes and to do. Let's go to tree, home. So you can also see that it's like a more another tree, but it's more of the child of the tree. Now let's go ahead and pass this on to Jason.
All right. Um, I'll now demonstrate our search capabilities, permission system, and diagnostic tools. So the file system includes a powerful search with wildcards and recursive options. We have find with the txt.
See,
Yep, and then it shows no match. And then we have find notes as we made that file. And then it shows we have the notes and its path. And then we have the stat, which gets detailed information about that file, and it shows all the statistics and all the numbers behind it. And then it shows complete in-node information, including permissions, owner, size, and timestamp. And then we go back to home Brandon. And then now our next major feature we have here is we implemented a multi-user permission system. And then we have three root users here with the and UID 0, 1, and 2. And then we have who am I here to check our UID. And then we start as root. We can change permissions using octal notation, just like Unix. And then as we can see, it's changed to 0, 644. And then mode 600 meaning the owner can read and write. And then we go into our next command, and then see the stats of that. Yep, just how it's, and we can see the stat of that. And then we can log in now as Brandon with the UID 1. And then we can see that we've now changed user, and Brandon can read his file, as we can see that. Next, we can see after that um, his user ID. And then we are now as, and then we can see that he can access the file and read it. And then now we can swap over to use the user as Eric, and with his user ID too, see that we've set ourselves to Eric as the user. And then he'll try to read Brandon's private file, which will fail because he's not Brandon. And then we get an error that returns as denied. And then we log in back to the root. And then since the root can access everything, we'll be able to bypass all restrictions to be able to read the file. We also added the file system statistics as a consistency checker as well for another feature. And then the it shows the blockage usage, the inode counts, and it even calculates the largest contiguous free space. As you can see, we're only using a few blocks out of the 100. And then we go into fs check, and then it shows that our consistent as our consistent checker, it validates our directory entries, link counts, and checks for duplicate block references, and also verifies the bitmap consistency. And then let me hand it over to Brandon now.
Hello, my name is Brandon, and I'll be talking about history, persistence, and some extra features and demonstrating our test files. So we can check a log of our command history by using the history command. Alternatively, you can use the log show to also do that. And you can see all the commands that we have throughout this presentation. And now we can test out the saving and unmounting feature. So first we'll save the image and then unmount the path. So now once the disk is unmounted, we can exit the program and then start up the program again with Python 3 CLI.py. And now we'll just mount the same image file, the test file system. So now it says it's mounted, and then we'll check our uh, path directory and see that our data persisted. All right, so now we'll start with trying to use our removal commands. So first we'll try removing a file. So we'll first remove the to do text from Brandon. Yeah, so now you can see that it's been removed. So now we'll remove a whole directory. So first we'll remove let me try removing Brandon. Yeah, so now we know that we can't remove a directory that's been populated, so we'll have to check for a directory that's empty. No, restart. I think we already went over 12 minutes.
I just keep it like this.